What if you built a skyscraper so tall its shadow touched the moon? A building with not 1,000, not 1,000,000, but 1,000,000,000 stories. A vertical dream so vast it would pierce the atmosphere, drift past satellites, and greet the stars with glass and steel. It sounds like the fantasy of a child, doesn't it? In fact, it was. A real question from a real child named Kira, age 4.5. But behind every wild question lies a doorway to understanding. Because when we imagine the impossible, we begin to reveal the edges of what's possible. So today, let's climb. Let's imagine what would happen if humanity built a building 1 billion stories high. Not because we can, but because imagining it teaches us something deeper about physics, the Earth, and maybe even ourselves. Imagine standing at the base of this building. Its foundation is anchored into the Earth's crust. Its first floors hum with life. Coffee shops, elevators, bustling people. The 10th floor feels normal. The 100th is high. The 1,000th is where most skyscrapers stop. But we're just getting started. By the time you reach the 10,000th floor, the atmosphere begins to thin. You're now higher than commercial jets fly. The sky has turned dark, not because it's night, but because you've climbed above the blue. You need oxygen masks now, and heating systems, because it's freezing. The wind screams like it's trying to tear the building from the planet, but you're not even 0.001% of the way up. Let's pause. What happens when you try to build something that tall? On Earth, even materials have limits. Think of building a tower of Jell-O. At first, it stands, but as you stack more, the weight causes it to collapse into itself. This happens to buildings, too, even made of steel and concrete. The pressure at the base becomes unbearable. The atoms in the steel begin to shift. Foundations groan. Eventually, even the strongest materials turn soft under the weight of themselves. This is known as structural compression. So to reach 1 billion stories, we'd need impossible materials, something stronger than any alloy we know, perhaps carbon nanotubes, or some undiscovered composite from the bones of neutron stars. Now, let's talk about elevators. Because you can't have stairs in a building this tall, no one would survive the climb. Today's tallest buildings already dedicate entire floors just to switching elevators. There are express elevators, sky lobbies, transfer stations. In a 1 billion-story building, half the space would be nothing but elevator shafts, unless we invent something new. Space elevators, maglev tubes, perhaps vacuum lifts that use quantum stabilization. Or maybe no one needs to move at all. Maybe every floor is its own ecosystem, a city floating above a city, stacked like geological layers. And here, we touch the first philosophical truth of the journey. The higher we build, the more we isolate. Let's keep climbing. At 100,000 floors, you've exited the stratosphere. You're now where low-orbit satellites live. If you pressed your hand against the window, it would freeze in seconds. Earth curves gently below like a blue marble. Clouds drift in slow motion. The air is gone. The silence is cosmic. You're in space, but still inside a building. How tall is 1 billion stories, really? Assuming each floor is 3 meters high, 1 billion stories equals 3 billion meters, or 3 million kilometers. For scale, the moon is 384,000 kilometers away. Mars, at its closest, is 55 million kilometers. Your building would stretch more than 7 times the distance to the moon. You wouldn't just scrape the sky. You'd puncture the gravitational hold of the Earth. And that is a problem. You see, Earth spins. Anything on its surface, buildings, oceans, is rotating with it. At the equator, that's over 1,600 kilometers at h. But the higher you go, the faster your building moves at the top, because it's traveling in a wider arc around the planet. Eventually, the centrifugal force from Earth's rotation becomes stronger than gravity. Somewhere around 42,000 kilometers up, you reach geostationary orbit, the place where satellites float above the same spot on Earth. If your building extends beyond that, The upper parts will feel like they're being flung outward. It's as if you're swinging a rope with a weight on the end. Too fast, and the rope snaps. Your building tears itself into orbit. Steel isn't designed to hold up a planet's rotation. And now we touch space debris. Low Earth orbit is full of abandoned satellites, rocket parts, and random metal fragments, all traveling at bullet speeds. Your skyscraper would become the most vulnerable object in the solar system, a fragile needle stretching through chaos. Imagine a shard of metal, smaller than your hand, smashing into floor 742,180 at 28,000 km/h. That's enough force to vaporize the room. Now multiply that by 1 billion. Still, let's pretend you kept building. Let's say you invented magical materials, bypassed orbital physics, and survived the debris. At the halfway point, your building passes the moon. From a window on floor 500 million, you could reach out and almost touch lunar dust. Tides would ripple strangely back on Earth. Gravity itself would warp. Light would bend around your tower. And on the very top floor, the billionth story, you'd be leaving the influence of the solar system. Drop a rock out the window, and it might never stop falling. Not down, but away. You could launch objects out of the galaxy just by letting go. The top of your building wouldn't just orbit stars. It would drift into the void, carrying the architecture of a question too big for Earth to answer. So why build it? Why imagine a tower we'll never construct? Because in trying, we learn the shape of our limits. In dreaming of 1 billion floors, we discover the pressures that crush, the forces that fling, and the beauty of holding on anyway. In fact, that's what science really is. Not a cold calculation, but a poem in numbers, a love letter written in physics and curiosity. And this question, what if you built a building with 1 billion stories? Isn't really about architecture. It's about wonder, about reaching upward, about seeing how far imagination can stretch before it snaps. And then imagining further. Maybe we'll never build such a tower. Maybe we're not meant to. But perhaps the real skyscraper isn't made of steel. It's made of questions. And it rises every time a child looks up and asks, what if? If this journey stretched your mind, even just a little, if it made you pause, smile, or wonder, then I invite you to keep climbing with us. Subscribe to the channel, leave a comment with your own impossible question, and hit the like button, not just for the algorithm, but because curiosity deserves to be celebrated. Until next time, keep asking the questions that feel too big. They're the ones that make us grow. And who knows, maybe one day we'll build something that touches the stars.